Hey, are you there? All right. Yes, I can. Uh,
Streaming yet?
I did start the stream, but I'm just streaming an image right now. It should be. So let me know
Good
if
deal.
is it there?
Nice. I'm checking right now. Yes, intro to Kubernetes stream starting soon. So,
Okay. So I can stream you, and then hopefully out of the speakers will go into the mic that's configured for Twitch. It is great. Uh,
no worries.
all right. So
Just want to.
let me know when you can see it.
I
Yeah.
can see it.
Awesome.
So
Can
we're
it,
gonna start in just a few minutes here, around 6:05,
let me pull up my chat here.
and yeah, just kind of chatting while we're waiting.
Oh, I gotta figure out how to get into that other chat. Oh, it's really weird to see me and you on the screen here.
So Jay, how long have you been working with Kubernetes?
So about 3 years now. I kind of made a transition in my career about 3 years ago. I went from a Windows engineer to a Linux engineer, so it was a wild ride for sure.
Okay.
Yeah,
So Linux engineer to what engineer again?
from Windows to Linux.
Okay.
Yeah, so I spent the last, you know, 10 years as a Windows engineer, automation engineer in the Windows space.
So PowerShell to Bash, is that the transition?
Really? No, it was PowerShell to YAML. Right? Or Ansible
Yeah.
and yeah, yeah. So, and I still use a lot of PowerShell. Actually, uh, one of the interviews that I gave at Red Hat when I was transitioning there was um, as a uh, I showed how you can use PowerShell with Kubernetes, and so it was
So
and either I
using
was
that
like, right, exactly, yeah. So
was
yeah, so I was
yeah,
patching clusters and
really been messing around with fish before you out. And you, I like fish a lot. Have you ever tried fish?
no.
Okay, it's a Spanish alternative.
Hmm. Oh, I know what you're talking about. Yeah.
Yeah.
All right. Well, this video watching
Apparently,
Twitch.
I'm not coming. But, is this better? Anyway,
Oh, you're not very loud.
yeah, it says I'm not very loud at all.
All right, I can
Hello.
make you louder.
Okay, and then I'll just do a little intro here in a moment. All right. I think it's about time we start. Jerry, you ready to go?
I think so.
Wonderful. I just want to say welcome to everyone to the May edition of Cincinnati Software Craftsmanship. We do this every month on the first Wednesday, and recently we've been doing it virtually via Zoom and Twitch, of course. This is the second virtual meetup, and I think it's been going very well. So we plan to continue doing virtual meetups until we are able to, until it is safe to begin doing in-person meetups again. I definitely enjoy the in-person meetups, but it's got to do what's safe. And just want to welcome everyone to the uh, stream, to the meetup, and I just want to thank Jay Ryan for coming on and teaching us a little bit about Kubernetes. So without further ado, Jay, take it away.
Great. Let me know. Let me see here. Let me close this Zoom meeting. It's really hard to manage two different streams at once here. Okay. I would ask if everybody can see my stream, but I think we are good. Let me just get my windows in place here. Okay, well, welcome. I'm Jay Ryan, and today we're going to be talking about Kubernetes, and this will really be introductory conversation about Kubernetes. Let me take my headset off here because I don't need that anymore. Um, and we're going to go over basically what it is, uh, what Kubernetes is. We're going to talk a little bit about the history of Kubernetes. And then I want to talk some about why I think you should care about it. And if you're here, that probably means that you do have an idea about Kubernetes, and you might have some feelings or thoughts around it, and you might just be exploring, and that's good too. We're going to introduce you to some key concepts, some terminology, so you can talk the talk around Kubernetes. I think one of the most important things when you're learning a new technology is to kind of get a firm understanding of it. So we're going to go over some of the architecture as well, how it works. And then what I really want everyone to kind of walk away with today, whether you're using Kubernetes in production today, or whether you're just learning about it or just learning how to spell it, a feeling about how a tool like Kubernetes can be useful to you or your team, and how you develop software, deploy software, support software. Um, so that's kind of the overview. But before I go too far here, sorry, I went to the wrong slide. Now I just ruined all of that. There you go. Okay. About me. So, my name is Jay Ryan, and I am a solution architect at Red Hat. My career path has changed many times, and so I thought I'd give you a little walk down memory lane about kind of where I started and my journey that got me here. So I started out as a musician, and as a musician, I was really interested in playing music and learning about music. But when I went to college, I decided to go for audio engineering. So I went to school for music engineering, and from there, I decided to become a TV salesman because that's what mediocre audio visual engineers end up doing. You can sell TVs. So from that path, I was really good at IT, and I'd always had that technical mindset. I'd always worked on computers. So I started out at the bottom. After I got out of college, I decided I wanted to go work in IT, but didn't have any IT experience. So I started out as repairing printers in a printer depot. And then from there, I moved on to repairing PCs and fixing PCs. Kind of think about pre-Geek Squad. I was fixing grandma's viruses on their computers. From there, I made it to the big time and got a job at a factory where I did IT support there, which involved crawling under desks in a forging plant, getting black from head to toe, plugging stuff in. Wasn't exactly my idea of what I thought, um, a career in IT might be for me. Um, from there, I became a system administrator. So this is the real deal. I moved into system administration. I worked for First Financial Bank for 9 years, and kind of worked in the Windows and virtualization space there. After that, I moved over to GE and was going to do Windows architecture for General Electric. And immediately after about 6 months of work there, my boss asked me to switch gears and become a Linux, move to the Linux team. So, I mean, I knew enough about Linux to be dangerous, but definitely not in the capacity that I had known for the last, 12 years in my career. So it was definitely a huge gear shift for me. But right away, I jumped in, kind of learning mindset, picked it up, and became a Linux engineer. And I moved on to what about this thing, Kubernetes? We really need to focus and get our hands around this at GE. So I kind of spearheaded that product at GE 2 years ago. Became the SME for Kubernetes and OpenShift at GE. And the rest is history, I guess. 3 weeks ago, I started a new job as a solution architect at Red Hat. And yeah, so my career, the reason why I went down memory lane is not to, show you, all of my accomplishments or anything like that. It's actually quite the contrary. We were talking in the Zoom before this meeting, and there were several of us that don't have traditional backgrounds coming into IT, coming into software development. So I just want to, it's hopefully it's an encouraging reminder that no one sets your career path but you. And just encourage people to continue learning as software craftsmanship would have you do, and follow your path. So enough about those things. Those things really aren't who I am. I'm really a husband. I'm a father of two boys who also like my red hat. I'm an outdoorsman. I love kayaking and fishing. I'm a really bad gardener. I think I know all the details, but I can't get anything to grow. And I like beer. So that's more of me. So back to the Kubernetes. Um, let's see here. I got a little fancy. Okay. All right. So what is? All right. Let's not mess that up. Okay. What is Kubernetes? You may be. You may find that you're asking yourself what Kubernetes is. So Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. That's straight from the Cloud Native Computing Foundation's website. That doesn't really give us a lot of ideas, and it also throws in some other words that we might not be familiar with. So, what in layman's terms, what Kubernetes is, it's a scheduler for containers. Hey, we got a first chat. I see. Hello. It's a scheduler for containers. Now we may need to back up a little bit. I understand not everybody might be on the same page, so we'll level set. Let's talk a little bit about what containers actually are. So a container is a lightweight, standalone executable package of software that includes everything needed to run an application. So that's going to be the code, the runtime, system tools, libraries, settings, everything packaged that you need to run your application. And the container technology has actually been around for a really long time, but it's been popularized by Docker, which I'm sure most people are familiar with. And Docker really just came along with a really fancy way to package up this idea of a Linux container and make it really easy to use. Um, the next thing about a container is it is isolated from the rest of the system. So a Linux container construct really, um, uh, sorry, a Linux container gives you some isolation from the rest of the system. So there's constructs like namespaces and C groups um, that um, that can keep the bits inside the container kind of separated from the rest of the system. What that buys you is that gives you a lot of flexibility and portability when you can move when you move your application around. So that application can, when packaged up in a container and packaged up with a container image, can be portable to other machines. Anything basically anything with a Linux kernel, that container can then move to and run. And again, it has everything that it needs for that application to run. Um, Containers were great for developers. You can do it on your local machine. You can even develop on a Mac now. You can do things faster. You didn't have to wait for IT to provision you resources to do testing to get your code off the ground. So it was really a game changer in the way a lot of developers worked. Um, but more so than that, since this ecosystem has been developing, containers have really been an enabler for faster deployment cycles, more consistent deployments, and more secure deployments. That's kind of the DevOps type of model or DevOps type approach. You can go faster and be more reliable and more secure. You don't have to have trade-offs, one or the other. A waterfall approach might say, well, if we go slow and make sure everything's right, uh, we'll be safe. And DevOps kind of flipped that model upside down, and containers are a big enabler for that. I wanted to share this picture with you just to kind of get a feel. A lot of people can't compare containers to virtualization, and I don't really want to get into that here, but really when you look at the left side image, that's a virtualization environment. So that's a typical VM running an application. That VM sits on a hypervisor, which sits on operating system, and the hardware is then underneath. And a container, really because it's packaging up everything that application needs, um, is doesn't necessarily need a hypervisor to get in the way. It also isn't relying as much on that guest operating system. And so what I really want to focus on is this area right here in the that I've highlighted. And this is the area that was always the hang up and always the pain point when you're talking about developers running applications on VMs. Usually, everything from the hypervisor down was one person's responsibility or one team's responsibility, and maybe they managed the operating systems as well, um, but the applications were usually developers, and there was always this fight between what the developers needed versus what the operations team could deliver. And this area got really messy in between operating systems and applications. What packages are installed? How are they installed? What dependencies do I have? What other apps have different dependencies than mine that can cause problems? Um, and this was really where the cat and mouse game could happen. And containers really enable you um, to bring the supporting system with you, like I said, not rely as much on the underlying operating system, and get the same feel, consistency, and security anywhere those containers go. Okay, this is not a talk about containers. This is a talk about Kubernetes. So what Kubernetes does is it can take those containers and it allows you to really abstract away the details of the underlying infrastructure, right? Developers don't really need to worry about the stuff that's below that dotted line back on that last image. Um, Developers can take their containers and run them anywhere with Kubernetes. You no longer have to worry about how long it'll take to get your VMs, your cloud storage, your database, your load balancers, your DNS records. Um, Kubernetes can abstract away all of that infrastructure for you. So you really have one interface to work with, one layer of abstraction, if you will. Now, abstractions can be a bit messy, and that's okay. And that doesn't mean we can forget about everything else. Abstractions give us a convenience of not having to day in and day out struggle with the things that are underneath. So this idea of Kubernetes being the new kernel, I'll give credit to Jesse Frizzell for this. A lot of people are saying this now, and a lot of people have said this. A lot of thought leaders in the container and Kubernetes space. But I really want to talk about this for just a minute here, because I think there's a lot to this, because I think Kubernetes really goes well beyond just orchestrating containers. Um, if we look at Kubernetes holistically, and that its ability to abstract away not just compute and memory and CPU, but it can abstract away um, anything else that's really involved in that technical ecology of your application. So all of the components, um, whether it's hardware, software, drivers, uh, libraries that your application depends on, it can really abstract those away. And so if you think about if you're a Linux operator, if you understand Linux, and you may have compiled the kernel before, or if you've written kernel mode drivers before in your life, those things are hard. And I think Kubernetes similarly can be complex and can be hard. Um, but it's the abstractions that are built on top of the kernel that really makes the Linux operating system thrive. It really enables application developers to use the components uh, and the operating system in a way that can drive business value for them. And so while it's not a direct comparison, if we think about Kubernetes as a kernel for a data center instead of or even a kernel, a distributed kernel for multiple data centers or clouds, public or private clouds, you can make this comparison um, where there are reasons to understand the internals and to run the internals and to be a Kubernetes expert. But there's also a level um, um, of abstraction that happens there that can be very beautiful. And so if you don't need to operate if you don't need to operate the kernel and install kernel mode drivers or build Linux from scratch, right? You may not in the future, at least, you may not need to build Kubernetes yourself. So there's a lot of things evolving in the Kubernetes space around tools and techniques and ways to develop and use Kubernetes without actually having to be a Kubernetes administrator. So if installing Kubernetes is high on your priority list, you might want to take a look at your priority list and try to understand the reason why, the reason behind um, why you're interested in Kubernetes, and think about how it enables you to do what you need to do or do what you want to do, and less about the bits and the nuts and bolts of a new shiny technology. I'll get off that soapbox for a minute, and I'm sure we'll get back there in a few. So the history of Kubernetes. It's always good to learn about the history of something when you're trying to decide if this is something for me. So um, Kubernetes came from Google, and they released it in 2014, and it really came out of a need that Google had internally. Um, Obviously, Google is running things at massive scale, but they had been doing containers for more than 10 years at this point in 2014. Again, the Linux container is way older than Docker, and Google had been doing it, and they had learned a lot of lessons from running containers. Um, and let's see here. Yeah, and so one of the founders of Kubernetes had mentioned that Google was launching over 2 billion containers a week. And that's billion with a B. And as you can imagine, if you're trying to manage containers at that scale, you'd probably run into some problems and you'd learn some lessons. And so Kubernetes was based on Google's own cluster manager that they use to manage all of these containers across the globe, which was called the Borg. And if you're a Star Trek fan, you probably get that reference. The Borg, everything needed to be assimilated, right? Everything had to. It was one, you know, uh, race to rule them all. It was the Borg's mentality. Um, but the inventors of Kubernetes said this is an interesting technology. This is a great thing. This is something that we should share. But how Google was using Borg didn't really make sense to just hand Borg over or open source Borg at that time. So they said, what if we just start over? What if we write from scratch and we learn all the lessons we learned with the Borg, and make this thing that we can give away to the community? And so that's where Kubernetes came from. And Kubernetes is the Greek word for helmsman. And you may be thinking, please tell me in the chat here if I'm saying Kubernetes wrong, and you're not going to be my friend anymore. Because there's big debates on how you say Kubernetes or Kubernetes. I think if you studied Greek, it would be neither of those two. I think it would be Kubernetes or something like that. But it's a Greek word, and it's the Greek word for helmsman or governor. So this is the captain of the ship. So Kubernetes is the captain of the container ship. An interesting side note: the internal name for Kubernetes before they came up with this name was Star Trek related as well, but they couldn't get that past the legal team at Google. It was Seven of Nines, which is a Star Trek references to the Borg. But I find it interesting because I think Seven of Nines was kind of a lighter side, a more human side of the Borg, if you will. So if you can look at Kubernetes in that light, I think it's an interesting reference. Well, there you go. Somebody has posted the. Can you post that, B Cincy? Can you post that phonetically, please, so I can pronounce that? It's written in Golang. So the Borg was written in C++, I believe, and Golang was again, it's a Google kind of founded language, and has a lot of qualities that C++ had as well, and so that was the direction that they went in. And in 2000 and I think in 2014, I think it was the same year. Sorry, I didn't write that down. Google and the Linux Foundation formed the CNCF, the Cloud Native Computing Foundation, and they donated this project as their first project. And the CNCF since then has really grown and developed and flourished, and they have a huge portfolio of open source products that are in different stages of development and production. And the idea of the CNCF was that the projects would be open source and they would be all focused on how things operate in this new world, in this cloud native world where kind of the data centers and the clouds can be abstracted away. So this is the question that I think you should ask yourself with every technology that comes your way. I mean, technology flies at us 100 times a minute. There's new offers in our inboxes to download new trials of new things all the time. So when looking at Kubernetes, we have to give this a serious. We have to ask this question seriously. Is Kubernetes just a buzzword? Now, Kubernetes is a way to schedule workloads that are packaged in containers, and containers are very popular, especially among the developer community. But the question that I think you really should be asking, again, this goes for when you're evaluating any technology, is do I need it? What value does it provide to me? And the good consultant answer that you're going to get is always it depends. And it depends on a lot of things. If you're a developer, you you're using if you're already using containers today, if you're struggling, maybe getting your code to production, if the current methodology for getting your software to your customer involves trade-offs between security and speed and agility, um, I think Kubernetes can really help in that space. If you're a system admin or a DevOps professional, an SRE maybe, um, you know, and there's always this ooey gooey middle between the operating system and the application. Um, if you need easier ways to test upgrades, to deploy infrastructure, if you need better reliability, or if you need to keep the developers out of your hair, frankly, that are always asking for more resources than they need. Um, um, they're always, it seems like it's a constant battle a lot of times in a traditional um, IaaS or infrastructure as a service approach, where VMs get thrown over walls, code gets thrown back over a wall, and everybody's confused when things don't work correctly in production. I'm not saying Kubernetes is going to solve all these problems. In fact, I don't really think it will. Tools are usually less than 50% of the problem when you're dealing with deploying software. But I think Kubernetes is a tool that you should care about, though, and you should keep an eye on it. And I think is Kubernetes is able to align your infrastructure with your applications and what your applications are capable of doing now. Um, this is an awesome quote, and let me just read it for you here as I take a drink of water. You should be using tools and platforms that enable you to get business logic to production as fast, as safe, and as secure as possible. You should write this quote down because it's one of my favorites. See, this is when the room might chuckle, but I don't have that. I don't have the Twitch chuckle, but that's all right. Uh, yeah, no, this is me, and this is something when I was trying to drive adoption. Um, this is you know Kubernetes doesn't have to be the tool that does this, um, but this is where everyone's focus should be, right? The focus shouldn't necessarily be on which languages am I using and which frameworks and which infrastructure and which cloud I'm in and which cloud's the best. The focus should really be on whatever works the best for you and your business to ship things to customers. And in my opinion, Kubernetes is a really great tool for doing that. All right, so I want to go over some of the basic architecture as well. This talk isn't really about the nuts and bolts, the nitty gritty of how it works, but I think even if you're a consumer of Kubernetes and not a builder of Kubernetes, I think it's very important to understand how the components interconnect. And again, if we're talking about Kubernetes as the new kernel or the kernel for the data center, and we have that mindset, I think it's really important to understand how that architecture works and how it can benefit us when we go into that new mindset. So if we're talking about the control plane, so Kubernetes has two major components, and that's the control plane and a worker node. So as you can see in the diagram here, the control plane is on your left, and I think I can blow that up. I think I have another image of that. Yeah. Um, so on your bottom left, you have etcd, and etcd is a database, and it's a very lightweight. It's actually a key value pair, key value store database, and it helps keep the state for Kubernetes. So all of the persistent data that Kubernetes has about where all the workloads are live in this etcd database, and it's distributed across all of the nodes that are participating in the control plane for your cluster. Next up is the API server, which is kind of in the middle of the screen. It says Kube API server. That is the internal and external interface for Kubernetes. Everything, all the components within Kubernetes, um, they're connected via well-defined, very structured schema API server, and that will become really important as we talk more about how modular Kubernetes is and all the different components that can connect to it, and how you can use Kubernetes in the same way that Kubernetes uses Kubernetes, and what that means for extending Kubernetes. The scheduler, its job is to just place resources on nodes. And a resource from a Kubernetes perspective is a pod, and we'll talk about that in just a minute. But so the scheduler just says, and a pod has, I guess, well, a pod has one or more containers inside of it. And so when you deploy your container to Kubernetes, you deploy it inside a pod, and that pod, the scheduler, tells that pod where to go, when to go, and how to go there. The controller manager, manages the controller. So the basic concept here is we have an API server, we have a scheduler that tells things where to go, and we have a controller manager. And this controller manager is responsible for reconciling the state of the cluster with the state that you want the cluster to be in. It's sometimes referred to as the desired state, the actual state versus the desired state. So some technologies you'll hear talk about are desired state configuration, and that's kind of how Kubernetes works. So its job is to check and make sure things are the way that you've described them to be when you send a request. And so if they're not that way, it runs a reconciliation loop that does its very best with all of the knowledge it has to make what you've described accurate. And we'll talk. We'll go into a little bit more and show an example there of that. The cloud controller here on the screen, it's really there to show that the controller manager is also responsible for other controller managers. So again, how I said this was a very pluggable a very pluggable way. Kubernetes is more of a framework for how you can build services on top of Kubernetes. And so a cloud controller manager is a controller manager that manages clouds. And so things it can do is it can hook up to any cloud. It's kind of a obfuscation layer between clouds. And when I say cloud in this context, it could be on-premise hardware, it could be public cloud, it could be virtualization technology, it could be OpenStack, those types of things. So it can spin up nodes, it can check the health of those nodes, and it can query information back about it. It could spin up new IP addresses or routes in that cloud. It can create load balancers and things like that. When we talk about custom resources and operators, we'll get into more. We'll get into a little bit more about why that's such a powerful thing and why it's so important. If we think back to that kernel module, I'm sorry, if we think back to that kernel philosophy that Kubernetes is the new kernel, we can plug anything into this. In fact, Kubernetes has built these components to actually be pluggable. And I think I've heard about every single one of these being replaced by another product in people's own kind of implementations. Like, for example, I forget which vendor it is, but they've replaced the etcd database with a totally different database. I don't necessarily recommend doing that, but you really have that plug and play kind of model, plug and play approach. Um, all right. get ahead of myself here. The other component besides the control plane is the worker nodes, and so this is the kubelet is on every worker node, and it's responsible for talking to the control plane. So again, all the communication happens with the API server, and the kubelet is then responsible for getting that information and then doing what it needs to on each worker node. So every worker node in the cluster um, is capable of running pods, and the kubelet's job is to take direction from the control plane, and also to make sure that everything's healthy. It will, as the desired state of the cluster changes, the controller will tell the kubelet to destroy a pod or create a pod or modify a pod on a given worker node. Um, The container runtime is another very important component. This is how containers run on Kubernetes. So Docker is the most popular one that we've talked about before. But again, this is a pluggable model as well. So container runtimes can be container D, Rocket, Cryo. There's all sorts of container runtimes that can happen under the covers here. And its job, container runtime's job, is to manage that Linux container construct, right? So to create the namespaces and the C groups and to manage the networking and all of those things that all of those complex Linux technologies to make the construct of a container work. So that's the container runtime's job. The network proxy is kube proxy again by default and can be swapped out. Different vendors swap this out for different components. And it's really just a load balancer. It really just routes your traffic that's going into the worker node or out of the worker node to the correct pod. So you can have multiple pods running in your worker node, and it may or may not um, multiple pods running in your worker node, and you can have network traffic going to each of those pods through the kube proxy. I forgot to put the link to the slide to the Q&A. Sorry, give me just 1 second in the chat here. I don't know if that link will work. Sorry, I really wanted to see if this Q&A thing works. Let me just type this right here. Slides at goo.ly/MDYQ7. Now I don't see this chat is not as active as I'd hope. I'm really missing the interaction here. So if you do have questions, feel free to you can post them right here in the chat. The chat's not too crazy, or you can post them to that link there. I think that should work. You should be able to ask a question there, and I think it will notify me when questions get asked there. Anywho, let me move on. So the other components are the actual pods, and there's some other things that kind of run on worker nodes that we don't really need to go into. So back to the Kubernetes kind of declarative configuration model. So Kubernetes basic building blocks are these objects, and an object is an entity that is persisted in Kubernetes, right? That's more jargon from the documentation that doesn't really mean a whole lot. These are some concepts about Kubernetes that I didn't find out until well into my Kubernetes journey, which I wish that I knew at the beginning, at the start, of how the object model worked. And, you know, when declaring something to Kubernetes, it was really confusing, and I had a lot of trouble trying to understand what data to put where and how to configure the YAML files and things like that. So I hope this part will be valuable to you. But all objects so Kubernetes basic building blocks are objects. All objects have this group, version, and kind. And that is, if you think about it from a perspective of development philosophy. Your object. I'm sorry. So the group is the API. I got ahead of myself there a little bit. The group is what API you're targeting. So Kubernetes has a lot of APIs that you can target, and in this field is where you would put which API you're targeting, what version of that API you're going to target, and then kind is the type of object that it is. And um, so every object is going to have all of these things. They're going to have a group, version, and kind. They're going to have metadata, spec, and status. Metadata is just that. Metadata is key value pairs that can describe the object. They can be relevant to Kubernetes or relevant to your business or relevant to the things that you care about. So you could put in here the owner of an object or the owner of a container or a resource or an application. You could also put information in here that would help another pod access it. So like labels, if you think about in a cloud world, we use tags a lot to identify assets. You can put those types of labels here in the metadata field. Spec, this is where all the magic happens. So this is where your declaration of what you want to happen to what you want to happen in Kubernetes to this object. This is where you declare. So this is how many containers there's going to be, what image it's going to run, what what's going to happen with regards to how that object is going to perform or not perform. This is where then all the nuts and bolts. And again, every object has a very well-defined spec, a very well-defined schema, and that's part of what makes Kubernetes so powerful. And the status, this is that if the spec is what I want to happen, the status is what state the thing is actually in. So if I make a pod object and that pod object has not successfully completed yet, the status will tell me that. And so all of these objects are described in YAML, or they can also be described in JSON, but they're described in YAML, and then when sent to the API server, they're converted to JSON. Okay, so this is kind of what one of these looks like. Okay, Jay Miazga asks, what's the easiest way to mess around with K8s? I have a resource at the end, and I will share that with you. One of my favorite places to go is Katacoda, and I can show you that. You can do it all online. It's really, well, I probably won't have time to show it to you, but I have a link at the end to Katacoda. There's all kinds of labs out there that you can do for free, and then there's like a playground, Kubernetes playground. You can also do the Kubernetes on your laptop. You can install, if you have Docker on your laptop already, Docker now has a Kubernetes component to it where you can just instantiate a one node Kubernetes cluster right in your desktop. Okay, so this is what an object looks like in Kubernetes. And so we talk about this group, version, and kind. So here's the group. So for this specific object, I'm targeting the apps API is what I'm going to hit. And I want to target this specific version. Again, well-defined schema, a well-written API. If you know anything about microservices, you know that you better be versioning them because when a developer targets one version of your API and that changes, things can get messy. So, so group, version, and then your kind here for this specific object is a deployment, and we'll talk about what that means. You'll see some metadata there. You can put as many key value pairs in that metadata spot as you want. And then the specs section is next down there. And what you see in the specs section is the count of 3. So I want 3 of whatevers in this. I want to follow this template. And this template has a container in it. The container is hello world. It's using image hello world latest. It's pretty human readable, but yet machine readable, right? And that's whether you love or hate YAML, that's the way it goes. So I hear people cussing and discussing YAML all the time, and you know it's nobody likes it, but everybody, but nobody wants to use anything else either. So I I kind of like it. It's a very structured way to do things. And so this is back to that declaration, right? This is the spec. This is the make it so, right? This is when you're telling Kubernetes to go do the work for you. But sometimes when that status comes back, when that's the status comes back, that pod isn't ready, that deployment isn't ready, that deployment didn't work, right? That's kind of like Scotty saying back, hey, we don't have enough power. We 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 can't do it. Um, and I would give you my best Scotty accent, but I'm not feeling that today. Um, So yeah, so this is a idea. This is what the status might look like, and you can see here the ready is false, and so that control loop is going to keep trying. It's going to keep over and over and over again. It's going to try to make what you wanted to happen happen. And you see here for this specific reason, it's targeting version 1.14.22, and that doesn't exist at all. I fat fingered it. It's supposed to be 1.14.2. Um, so until I fix that problem, until I change that declaration of what I want, this problem's not going to get solved. This is what a status might look like if it returns successful. So the control loop says, okay, you're done. It's in the state that it should be. My job here is done. So you see the status true, and if I didn't cut off the bottom of the screen, you would see that ready equal true as well. So when everything's good, right? You get to warp speed. So the captain, Kubernetes, the captain gets to say, make it so, and if all is good, then we go to warp speed. Okay. Um, Pods are a concept in Kubernetes that a lot of people get confused about, or a lot of people might not quite understand when you're first getting into it and you're familiar with containers. Pods are something that can trip people up. And I think if you follow these rules, it's pretty straightforward. Um, so a pod is the atomic unit of an application in Kubernetes. So Kubernetes acts on pods; it doesn't act on containers. A pod is can contain one or more containers, and these are the key things right here that share a networking space. So that's an IP address, a Linux namespace. So that's kind of that tenant boundary. Um, Storage. So all the containers inside a pod share storage, and it also shares a memory space as well. So a lot of people are trying to ask the question, well, how many containers should I put in each pod, and how many pods should I have, and should my app be, oh, should all my containers be in one pod, or should they be in separate containers? Um, if you follow these guidelines, that question will answer itself. Uh, the general rule of thumb is to never put more than one container in a pod unless you have to. So the idea is uh, these processes, if you're going to put more than one process or more than one container in a pod, they should be really tightly coupled. So we're talking about things that may have to talk over localhost, so things that can't be addressed by an API, things that have to share the same IPC namespace, that use semaphores or POSIX, right? Some Linux construct to talk to each other. So a lot of times these might be legacy applications, that pieces of an application. If you're containerizing a monolith, it might be hard to get those two containers to talk if it's not talking over a TCP stack or HTTPS connections. Um, if they're tightly coupled, like a log watcher, maybe your monitoring service, or a networking construct, these things could sit inside a pod as well, alongside your application. So think about in terms of maybe I always have to send all my logs to a certain tool at my company. Um, My application might write logs to a disk, right? And I'm sharing that storage with another process that can grab those logs and send them off to my log management, my log aggregation application. So other than that, you really want to stick to the one container per pod, unless right, unless it's I think of it as an exception to the rule. The next construct in Kubernetes, let's see. Can you give an example of a group and a kind? I think I did that with that. So the group here was apps, right? Version is v1 beta, and deployment is the kind here in this example. Each of these resources that we're talking about now are kinds. So this pod is a kind. Service, which we're going to talk about now, is a kind as well. Is Kate's pronounced Kate's or Kate's? I say Kate's. Again, it's the tomato, Kubernetes. Um, uh, K8S. Yeah. I call it Kate's. There's other products out there as well that kind of play on that that wording. If anyone in the chat could say where they got the Kate's analogy from, does anyone know where Kate's comes from? I'd like to see if anybody can answer that question. Okay, so service is the next building block we're going to talk about here. And a service is just a networking construct to abstract away the pod. When we're talking about containers and talking about pods, we're in a cattle-like mentality. This is not pets. Pods can go up and can go down. If you imagine Google spinning up 2 billion containers a week, we care way less about those containers and those pods than the application, right? We're abstracting away all of those things, and a service abstracts away how many pods are behind the service, pods going up and down. This is a way to have your zero downtime patching, your upgrades, your seamless upgrades, that sort of thing. There are three basic types of services. A cluster IP is the most basic type of load balancing service, but it's internal to the cluster only. So let's say you have a database that's also running in your Kubernetes cluster, and it needs to talk to your web front end or vice versa. Cluster IP would be the right kind of service for that situation. Again, so it's going to have its own IP. The service is going to have its own IP, and it knows all of the IPs of the pods. So anytime that a pod gets spun up or spun down, and there's a service in front of it, the kubelet notifies the service and says, oh, by the way, there's a pod over here, and this is its IP address. And so when things are connecting from outside of from inside of the cluster, everything is going to connect through the service IP address. Okay, node port is the next kind, and this is similar to, this is kind of like cluster IP and. So cluster IP and it exposes it on the host. So the host then, so you can then access from outside of the cluster. So think about it when you run a Docker command, you say Docker run -p, and you map port 80 to 80 to port 80. Node port is kind of doing the exact same thing, exposing that port for your service out to the rest of the world. And the third kind is a load balancer type service, and this is again where this modularity and this ecosystem, this Kubernetes ecosystem, really starts to thrive. This load balancer can integrate with third parties. So if I'm a load balancer company, I can write a load balancer type of service, and it can have all the details about how to configure my load balancer that may be even sitting outside of Kubernetes. So for example, if I'm running in AWS and I spin up a service of type load balancer, then this can actually go and create an AWS load balancer for me. And hook it up directly to my application. And then again, no matter how many pods behind my service are going up or down or IPs are changing, the service IP doesn't change, and the load balancer knows exactly how to connect. And then The integration can also send health information to the load balancer so you know which pods are available, which pods aren't available. Okay. All right. Kubernetes. How coupled should your pods be? It depends. I think you're baiting me there. So again, um, your pods don't have to be coupled at all. It just depends on the application infrastructure, your application, the way that your application is deployed. So if you have multiple applications that talk to each other, then that would work the same way whether it was inside the Kubernetes construct or outside the Kubernetes construct. Okay, other objects in Kubernetes that we should care about, we should think about are the deployment types. So deployments are ways to interact with pods and ways to create pods. So a lot of best practices will say that that you should really only be working with deployments. So deployments, I'll get here in a little bit. So deployments create replica sets, and replica sets create pods. When you spin up a pod without a replica set or a deployment, it's called a naked pod. I know, everyone giggle. It's called the naked pod, and it's really not a good practice. So pods live inside replica sets, and all a replica set do is say it says how many pods should there be, and that's it. So that a replica set is the most basic controller. It just says you say replicas 2, and it makes 2 pods. You say replicas 1, it makes 1 pod. You say replicas 0, all the pods go away. Um, Replica sets are usually wrapped up into a deployment. Again, so pods inside replica sets inside deployments. And a deployment's a little more complex. It gives you the flexibility to declare how you want your pods and replica sets to work. So it's going to be the thing that says, okay, where do I want these pods to run? And what it's going to ask, what is running. It's also going to be able to describe what services and resources are available to it. Maybe you have an amount of memory that you want to give to your containers. You have file systems that you're mounting in, volumes that you're mounting in. That's going to be described in the deployment. Environment variables, things like that can be described in your deployment. Configuration settings and the like. It's also going to have policies for how things should behave. So when a pod gets deleted, what happens, right? Does a pod automatically spin back up? Or when the image changes, what things underneath, how is the deployment going to behave? So things like rolling back or scaling up or pausing deployments. It's going to check against the current state. It's going to check against current state and make the change. So if you have a rollout policy, that says you always have to have 2 of these pods running at all times, and 1 gets deleted, the deployment is going to say, "Hey, controller, give me another pod." Rollback, scale up, roll out. Okay, I just said that. All right, time is flying by here. Kubernetes deployment types. Okay. Here's a few more. We're going to go through these really quickly here. A few more different deployment types that you need to know about. You definitely need to know about them, but they're a little less common. A stateful set. So if you have stateful workloads, if you want to run databases, things that keep state, maintain state inside Kubernetes, a stateful set is probably your best bet. Now, again, stateful sets were an afterthought in Kubernetes. The initial developers didn't even want to include them. There was a big internal debate at Google about should we even allow stateful apps inside Kubernetes, because the Borg, the predecessor to Kubernetes at Google, all of their state was managed with a whole nother system. So they didn't run databases in Borg. So stateful sets is kind of an afterthought, but it's a special kind of deployment type. Um, it offers stable and ordered constructs, so it's more of a pet actually than a cattle terminology. So if you, I just kind of gave it away, but my next question in chat was going to be if you know what the original name for stateful sets was in Kubernetes, add it to the chat here. Uh, okay, and volumes scale out with your pods. So in a traditional deployment, when you say replicas 2, um, you're not going to get new PVCs or volumes created with those new pods. When you scale up a stateful set, a new volume gets created with every pod that's in that stateful set. Just because if you're running a distributed database, you're going to need that data when you scale the replicas. Daemon sets, these are another special kind of deployment type where it runs on a defined set of nodes. And as a node gets configured, gets added to the cluster that matches what the daemon set spec says, right? So all nodes in AWS or all nodes that are in this region or all nodes that match this criteria. As those nodes get added to the cluster, this pod would automatically start up on that node. It's really useful for like infrastructure services. Most developers wouldn't really care or need daemon sets. In a lot of clusters, daemon sets are run for like logging or monitoring, security services, tools that you would need to run on every host in the environment. And cron jobs. So cron jobs are just exactly what you think they are. It's kind of batch processing. You get a server-like experience. Serverless-like experience. And so you give it a cron schedule and it will launch the pod. It will execute whatever bit of code you want to execute inside the pod. And when that process exits, your pod will go away and it'll run the next time it's scheduled to. Some more basic building blocks of Kubernetes. So when you're building containers, you don't want anything stateful inside those containers. So all the places where you're going to need to manage state have to be outside of that container construct. So Kubernetes has objects that it manages like volumes, config maps, and secrets. And these are all really basically the same thing under the covers, or they get consumed by the pod or the containers in the same way under the covers. A volume's basically just a directory on a disk. So that could be a shared volume to that host, it could be a network attached volume, it could be on SAN storage or cloud storage. Kubernetes, again, will obfuscate all of that away for you and just present a volume. And you can have different types of volumes for different types of underlying storage as well. Config maps are a way to get your code, your settings, your configuration into a running container or a running pod. So you may have done a Docker, you may have like mounted a file path or something like that with some environment variables or something like that in Docker before. This is how Kubernetes handles that, is with config maps. And again, just key value pairs that you can load into the pod on runtime. And secrets. Secrets are exactly like config maps, except they store their data a little bit differently. It's obfuscated. It's obfuscated for users outside of the namespace. I'm sorry, it's obfuscated for users inside the namespace and secured with memory because the memory is not shared. The data is stored in RAM, and it can be encrypted now in the later versions of Kubernetes. That etcd database can be encrypted, or there's third-party plugins that can integrate here, and you can store your secrets in like a HashiCorp Vault or CyberArk or something like that. Now, back to the true power of Kubernetes here is extending Kubernetes. And there's a huge ecosystem around Kubernetes and the way that that you can extend it. So basically custom resource definitions basically a free for all resource type. And so that's a resource type that I can use to define my own resource types within Kubernetes. So let's say, for instance, I would like a J resource. So instead of pods, I want to deploy J's to all the clusters. I can do that. And if I use the custom resource definition, I can build my own schema for what a J looks like. This one has to have glasses, and this one has to have shoes, and this one has to wear a red t-shirt. I can build all of that into the schema of my custom resource, and I get all of the benefits of the Kubernetes API, all of the high level abstractions. I get the rich data model, right? I get everything that I get with pods and deployments and all the other objects inside of Kubernetes. I get all of those things from my custom resource. So as Kubernetes, becomes more of that kernel for the data center model, more and more of these Kubernetes custom resources can get onto the platform, the more richer the development experience can really be. Your resource becomes a first-class citizen in the same way that I would do a kubectl. So kubectl is the CLI tool for Kubernetes. In the same way I would do a kubectl get pods, I could say kubectl get J, right? And it would give me all the information back in the same way. It builds all of that for me as well. And I'm kind of starting to talk about operators a little bit, but the operator pattern is basically pairs up these custom resources with a custom controller. And so not only can I build a custom resource, but I can also build a controller that allows me to program specific knowledge about my object and about how Kubernetes should deal with it. So imagine if you're a database developer, or a database product like MySQL, and you want to build an operator. So you want your MySQL databases to be available in Kubernetes. You want end users to just be able to say, kubectl create MySQL, and then give it all of their schema that they want. I want this many replicas of MySQL. I want you can do that. You can build custom resources and custom controllers yourself. But there's been this operator pattern developing, and I'll share a resource of that here at the end for how those operators work. And the operators are really nice because not only do they enable deploying special things, unique things to your business or to a product, but they allow you to manage those things, kind of the day two operations of those things. So think about not only just deploying a MySQL cluster, but what would it take to patch it? What would it take to run maintenance on that? What if I want to update my statistics or do indexing or things like that? And the sky's the limit, right? Anyone can build these operators themselves. So in closing here, I hope you guys got something out of this talk. Again, this is kind of more of a high level, kind of a thought experiment on what Kubernetes is and how it might help you when you're choosing whether Kubernetes is right for you. The three keys here is speed, consistency, and security. You don't have to trade off one for the other. Kubernetes is a big enabler for DevOps and can help you in that track. So Kelsey Hightower explains the Kubernetes pattern really is that infrastructure as data, and I really like that idea where we talk about infrastructure as code, we talk about configuration management, where you can write code and check it into GitHub, and you can make systems do things. But this next evolution really is infrastructure as data, where you're handing the computer a data model, right, for the way that you want things to be. and the computer just makes it happen for you. You don't need to use those programming constructs like loops and conditionals when you're programming Kubernetes. You just change the inputs to that data model, and Kubernetes does the hard work for you. Uh, so that's my closing thoughts there. Now, for the last 3 weeks, I've worked for Red Hat. I would be remiss if I didn't mention that Kubernetes is really hard to run yourself. There's a lot of vendors out there in the space. Red Hat's been doing it the longest, um, and they're the biggest player in Kubernetes in for the enterprise. And we have over 1,000 customers that run this thing in production. That's all I have. Okay, my resources I promised at the end. The operator framework, again, is where you can see all the operators that the community has developed. Catacode is a great place for your playground to go learn more, to dive in, a link to the documents, so on and so forth. With that, I will jump back on the Zoom meeting, and I hope everybody had a good time. Bye.